So if you look, you can see some of the division problems that are starting, and depending on who you had as a teacher in Algebra 2, you may or may not have done polynomial long division or synthetic division just because we do teach it in pre-calc. So, we're going to take the number 19 and we're going to divide by 5 like when we were little kids. Does 5 go into 1? No. Does 5 go into 19?
Yes.
How many times? 3 times. So, because 5 goes into 19 3 times, I write the 3 above the 9, right? What do I do with that? What's next? What do we do?
15 under 19.
Where did 15 come from?
That's a different one.
So tell me what you're doing.
Oh. This 5 times 3.
You take the 3 up top and multiply by 5 all front. 15. So then we write that here. Good. Yeah. Just I wanted to check. What do you do now?
Subtract.
You subtract. Okay. So now 19 minus 15 gives me a 4. Do I stop?
No.
Well, now we talk about I either stop or I don't, and it depends on kind of what grade you're in. When you're in 3rd grade, you stop, right? Because 5 no longer goes into 4, right? But if you get into 4th or 5th grade, then you learn what a decimal is, and you put the decimal in, and you bring the 0 down. So we could continue on with, put the decimal point there, which is going to allow me to bring the 0 down. How many times does 5 go into 40?
0.8.
So I put the decimal point there, and I get 3.8. Because 8 times 5 is 40. I subtract and get 0. Now, so your answers are, if you're in the 4th grade, you say my answer is 3.8. If you're in the 3rd grade, what's your answer? Your answer is 3 with the remainder of 4. Or, some people might have said 4/5. Because we had a remainder of 4 and I was dividing by 5. Now, you guys are high schoolers. What's 4/5 when you compare it to 0.8?
Same thing.
It's really the same thing. So that's how you do long division. Is 5 a factor of 19?
No.
How do you know?
It's going to be.
Yes, it did.
It's not a
3.8.
whole number. It's not a whole integer.
Okay, not a whole integer, right? So we consider factors. We consider factors to be whole integers. Like 36, 6 going into 36 goes in there 6 times. 6 times 6 is 36, right? That means it is a factor when you get a remainder of 0 without using decimals. Okay? So when we get into polynomial long division, it's a way of taking polynomials and determining if we do or do not have factors. So we're taking 2x cubed minus 5x squared plus x minus 8. And we're dividing by x minus 3. So we've already written it out for you. We only worry about the stuff that's on the left. Okay? Which is kind of nice. So I want to figure out how many times does x go into 2x cubed. So the first couple times I do this, I bring stuff over here. I take what's on the left in the first step, which is 2x cubed. I'm dividing by x. That's on the left of your divisor. So what's left over? Okay, so if I write a 2x squared up top, the point of polynomial long division is we're starting with the cubic, and we want to continue to break the polynomial down by bringing it down 1 degree. Okay, bring it down a degree, bring it down a degree until you get your answer. So now what did we do before? We took the number up top and multiplied by what's out front, correct? Well, there are two things out front. So what's 2x squared times x? 2x cubed, right? And what's 2x squared times negative 3? Negative 6x squared. The point of this is we always want these two things, the 2x cubed, now it's 2x cubed underneath it, we want those to be identical. So some of you will be able to look at this and say, oh, what do I have to put here so when I multiply by x, you know, it's exactly the same. We're going to put that in parentheses. And what did we do? We subtracted. So what is 2x cubed minus 2x cubed? 0. That's our goal, is to get that 0. Now, be careful. What's negative 5 minus a negative 6? Positive x squared. Now we can just bring down these other terms. So we bring down the x, bring down the minus 8. So I'm going to pause it. You can ask some questions. So after the first step, you notice what's in blue. What degree polynomial do we have in the blue? Squared. And what did we start with? Cubed. So we're down from a third degree down to a second degree polynomial. So we're making progress, and that's the key. Now, the thing on the left is x squared. And it's being divided by the thing on the left there, which is x. So when you get done with that, you put an x up top. X times x is x squared. X times negative 3 is negative 3x. Now, you always want to be careful that you're lining up like terms. You know, if you get, you don't get an x term, you only get a constant, then you should put it underneath the constant. So now when we go ahead and put it in parentheses before we subtract, notice we have x squared and x squared. So when you go x squared minus x squared, what do we get? 0. What is x minus a negative 3x? Because it really is, you're adding now the 3x. So 1x plus 3x. And then we're going to bring down the 8. How do I know when I can stop? You watch degree. 4x is what degree? First degree. X minus 3 is what degree? First degree. So as long as the degree down on the bottom here, your answer, is more or equal to the degree that you're dividing by, you keep going. Once it's smaller, just like when you're a kid, we're not going to the decimals here. So once it's a smaller degree is when you stop. So then I'd grab my 4x, pull it off to the side, and I would divide by x again. So notice, in the red and the blue and the green, I'm always dividing by this x that's sitting out front. And when you cross those off, you put a 4 up top. And then when we distribute, 4 times x is 4x. You always want those two things to be the same. What's 4 times negative 3? Well, that's negative 12. Put it in parentheses before you subtract. 4x minus 4x is 0. Negative 8 minus a negative 12. So negative 8 plus 12 is, can I stop? That's finally a 0 degree. I'm dividing by a first degree, so it's smaller degree, so I can stop. And then maybe you just go remainder of 4. If you do work out of the book, they will also write it a remainder of 4 x minus, over x minus 3, what you divided by. So that's your first example of polynomial long division. Your goal is to slowly break it down. And then the final question is, they would ask you, is this a factor? Is x minus 3 a factor of that cubic?
No.
How do you know?
It's not going into like a integer. There's no
Yeah, we didn't get the remainder of 0. If we don't get the remainder of 0, that x minus 3 is not a factor here. So this division algorithm, they're just talking about kind of names of things, and it's not something that you have, on the exam. I don't say, hey, what's your divisor or anything like this. But if you talk about factoring something, let's take the number, let's take like 48. So 48 might be what's called the dividend. It's something that you're starting with. D of x is what's called your divisor. What are you dividing by? So what happens if I take 48 and let's say I divide by 2? What's 48 divided by 2? 24. So 2 would be the divisor, 24 would be the quotient, right? Because when you take 48 and you divide by 2, the quotient is always the answer of a division problem. And what's your remainder? So I wouldn't necessarily write it if I had a remainder of 0. What happens though if I do maybe the same number, 48, and I divide by 5? So 5, if 5 is my divisor, 9 would be the quotient, because 5 times 9, that's the most 5s we can put in there, right? So that's 45. What's your remainder? Plus 3, maybe you'd say over there. So the textbook at times, if you do your homework again, will ask you to write it in this form. They will say write it in the divisor, quotient, and remainder form. This is what we have up here. That's good enough. So on the exam, when we ask you to do one polynomial long division problem, all I'm doing is checking, do you have it set up correctly? Are you going through the steps? What kind of remainder do you have, and what were you getting for answers? I'm not looking for a specific form for you to write it in. And then obviously, when your remainder is 0, that's telling us that we have a factor. So if I divide this one now, I'm going to move a little bit faster on this division. We're dividing by the quadratic. So we have 3x cubed minus x squared plus 5x minus 3. And we are dividing by x squared plus 2x plus 4. Maybe I won't move as fast as I thought. I'll wait a second. I'm going to give you an opportunity to put the number up top that we need. Now, for some of you, you can tell me by looking at it what number has to go here so that when I multiply by x squared, I get 3x cubed. If you can't do it mentally, do not be afraid to take the number on the left, in the blue here, write it off to the side. Take the number in red, the one that's on the left, put it underneath. So you always take the numbers that are on the left and do your division and cross things off. So do that quickly. I'll give you a couple seconds. What do I need here? I need a 3x. Because 3 times 1 gives me 3. X times x squared gives me x cubed. I need those two numbers to always be the same. So when I do my subtraction, they'll get rid of the cube terms. But we have to make sure we do all the red numbers. So what's 3x times 2x? 6x squared. 3x times 4. 12x. Put it in parentheses before you subtract. So 3x cubed minus 3x cubed is 0. We want that every time. If you subtract and you don't get 0, you've done something wrong. What's negative 1 minus 6? Negative 7. Negative 1 minus 6. What's 5 minus 12? Also negative 7x. Bring down the 3. Can I stop? No. Orange is x squared or second degree. The red is second degree. They're equal degrees, so you have to keep going. You don't stop until this stuff over here is smaller degree.
Right, but is like that second degree in the red?
Yes.
Or,
Oh, second degree.
yeah, so once it gets smaller, it's first degree.
Yes. Once it hits a first degree, we can stop. Yep. What do I have to put up top so that when I multiply by x squared, I get negative 7x squared? Negative 7. So negative 7 times x is negative 7x squared. You want those two to be identical. Negative 7 times 2x. Negative 14x. Put it in parentheses. Subtract. Negative 7x squared minus a negative 7x squared will be gone. Careful here. What's negative 7x plus 14x? And then that 3 comes down. Uh-oh. Uh-oh. Oh, it's still recording. Okay. Bring down the negative 3. This is, we can finally stop maybe. I don't know. I see less hands. See, this is one of those easy things. Okay, so I need to go back to purple. Yeah, I forgot to take the negative 7 times the 4, which would give me negative 28. Thank you. So the parentheses should not have been here. There you go. Thank you. So then when you do this one, you would end up with negative 3 minus the negative 28, which is really plus 28, so we're getting plus 25. Thank you. Anyway, so that's just a remainder. Now, I don't need you to write R next to your answer up top. Okay, it isn't something that's necessary, so we're done. Again, when you look at a cubic, we can use polynomial long division to help us determine whether or not these things are factors. So is that quadratic a factor of the cubic? No, I didn't get 0. Okay?